In this video, we are going to talk about the model view controller pattern. So first off, we need to talk about what design patterns are. So a design pattern is just a general reusable solution to some program, to some problem in software design. Okay, so it's basically a template where you can follow that template to solve problems that crop up uh, on a frequent basis. All right, and so the design patterns they're going to describe the objects that make up the design pattern, um, and their relationships to one another, but it won't be super specific about the details of the objects. So it is just kind of a general overview of how to approach specific problems in software design. And a lot of times these patterns will apply not to the whole software system if it's really complicated, but generally they'll apply to subsystems of the software system or small parts of the software system. There are such things as called architectural patterns, and those are more global in scale as opposed to the local aspect of the design patterns. And an architectural pattern just expresses a fundamental structural organization for the whole software system. Okay, so the architectural pattern will describe the subsystems that make up the complete software system, their responsibilities, and the rules of interactions between the different subsystems. And so it's a basic overall guide as to how a complex piece of software might be put together with different subsystems. So you might have a subsystem that controls the user interface, one that controls calculations that are going on in the background, and those sorts of things. In an architectural pattern, again, the implementation details are not specified, so it's not going to be a bunch of lines of code, that are written out. It's just a general overall top view description of the pieces that make up a software system and how they interact. Okay. All right, and then a framework. A framework is a partially completed software system that provides a reusable architecture. So some of the code has been implemented in the framework, and then you can basically build onto that framework to make add details and components of your software that aren't in the framework. So you can start with the framework and specialize, add pieces to it, and make your own application off of that. So some of the work has been done and some hasn't. And with what we've been doing with JavaFX, you can see like the application class that we've been using. You can kind of think about that as a framework. There are things that have been implemented that we don't have to worry about, like what happens when the user clicks the X on a window or maximizes the window or minimizes the window. All of that stuff has already been incorporated into that application package, and so we're just kind of building on that application package. Another example is, say, in web programming. That's when you're writing programs that run primarily in a browser. There's a lot of frameworks available for various languages, and with those frameworks, a lot of the underlying details have been taken care of for you, so you don't have to do everything from scratch. And you would just start with the framework and then add your code to the framework. Okay. So that differs from the patterns, which are just general descriptions of things. A framework actually has some implementation details in there. All right, so with GUI applications, that's what we're writing in this class. There are lots of common tasks that are available or that need to be done. Not with every program, but many programs have to do the following things. Number one is to load data from an external source. If you want to have data that's persistent, in other words, if the power is turned off to the computer, but you want that data available next time the computer is turned back on, well, then what you're going to have to do is load that data from an external source, and also, right, store data to an external source. So maybe like in the cloud or on the database server or on the hard drive. So loading and storing data from external sources. When the program is running, the program is going to have to keep track of the data that's being used in the program. That's a common thing. The user interface, that's something that's going to have to be done, right? If you're using a GUI program, is to lay out the user interface, and then the data that's being manipulated by the program is going to have to be displayed to the user, right? Your program is going to be keeping track of some information, and the user is probably going to want to see that information at some point. Okay, so that's another common task. And then the last one here is to handle user actions. We've already been talking about that somewhat with events that get triggered, when the user clicks a button or maximizes a window or enters some text in a text field and presses the enter key. What happens when those actions are taken by the user. All right, so those are all very common tasks related to GUI applications. And so almost every GUI application that you write is going to be doing these in some form or fashion. All right, so that leads us into the model view controller pattern. And the model view controller pattern is an architectural pattern for making GUI applications, also web applications, right, and other types of applications as well. All right, so when you hear people talk about the model view controller pattern, there are a lot of different versions and variants of that pattern. So you'll hear people say, describe some architectural pattern, and then somebody else will say, well, isn't that more like model view, whatever? So there is some consensus about what those architectural patterns look like, but I don't want to go into huge amounts of detail about those patterns because it's, number one, not consistent. Number two, probably beyond the scope of what we're doing here in this course. And there's lots of different opinions about those. All right, so this source that I have here is a good source to me. If you look up the model view controller pattern on this blog, it goes into some pretty good detail about the history of it and some of the different variations. And I'm just going to leave that to you. We're just going to talk about a very general idea here when we're talking about the model view controller, and we're not going to dwell too much on the details of the variations between the different patterns. Okay, so just the fundamental idea from the model view controller pattern, right, is the model view controller pattern is going to separate the application logic from the presentation logic. So what does that mean? So the presentation logic would involve displaying things to the user and how the user can look at the data. So the graphical user interface and how things should be set up in that. And then the application logic is basically the calculations that are going on in the background, the events handling, and then also the data, right, that the application needs to run. All right. And so how the model view controller pattern handles and makes that separation is it divides the application into three distinct and fairly independent parts. All right, and those independent parts are the model, the view, and the controller. Okay, so we've already basically been talking about two of those three parts, and that would be the view, that's the user interface, how the data is displayed to the user. Okay, the controller, right? The controller is the event handling that we've been doing. When the user clicks on a button, something's supposed to happen. The controller, right, is handling that code. Okay, and then the part that we haven't talked about so much is the model part. And so the model part is going to handle the underlying data that is the application needs, right, to in order to do its job. Okay, so view is the user interface, right? The controller, roughly speaking, is the part of the application that's going to handle the events, right? The event handling part. And then the model is going to be the unit of the application that takes care of the data. All right. So let's go into each of those parts, starting with the model first, since it's the one that we've talked about the least. All right. So the model part of the application is basically the data manager. It manages the data that's needed by the application. And the model could be a lot of different things in your application. For a simple program, it could just be a single variable that holds on to some information. It could be more complex. It could be a collection of classes, right, interacting with a database. So obviously, the more complex the data in your application is, the more complex the model is going to be. Okay. But generally for us, it's going to take the form of a class, another class, okay, in your application. The model usually does not contain the control code. That's, like the code that would be in the controller that does the event handling and things like that. And it usually doesn't display the code either. That's taken care of by the view or the controller in some combination, okay? So the data manager, that's what the model is, all right? And we'll give some examples, more concrete examples of this later. The view generally provides the presentation of the model to the user. The user detects the user action, so the user clicks on a button on the user interface and passes that information off to the controller. So we've been doing this all along in JavaFX, right? How we have been implementing this is with our FXML file, right? Our FXML file describes the user interface, okay? And we go into Scene Builder, lay out our scene, right? And we're creating that user interface, and then we are adding event handlers, right? That mechanism in the FXML file, those event handlers are noted, right? And so as soon as a user interacts with that user interface, like click a button or press enter in a text field, it passes that event object to the controller. All right, so that's the view. The controller, right, it's going to respond to user input and it's going to update the state of the model. All right, so the controller here is going to interact with both the view and the model. So it's kind of an intermediary between the data manager and the presentation, okay, part of it. And so for us in our JavaFX code that we have been writing so far, right, for every time we have a scene or then we have been creating a controller class for that scene. And so that's the controller. That's where we've been putting our input, our event handling code. Okay. So for us, it is a class, right? The controller class. And, if you have multiple scenes, you might have multiple controllers. So not only you might have a controller for the application as a whole, you might have controls and controller and views and models for smaller parts of the application as well. All right, but for us, it's the controller class that we've been using so far. Is mainly how we've been doing that. All right, so some advantages of separating the presentation from the other parts of the application. Different developers can work on the different components of the application. You have some person who lays out the uh, user interface, some person who works on the database part of it, the model part of it, and another person who works on the controller part. That can be separated out and done by different developers. Um, Secondly, related functionality is grouped together in the program rather than scattered throughout many different parts of the program. So if there's some issue, you basically kind of know it's easier to track down, where that might be. The some issue with the user interface, well, that's going to be in the view part of the program. If there's some issue with, you know, actions taken by the user or not, there's no response or it's not responding correctly, that's probably in the controller. And if there's some issue with the data's not correct or that's probably in the model part of the program. So rather than being all mixed out throughout a single program, it's separated out. And the third advantage is changes to one part of the program can be made without impacting other parts of the program. So maybe you have, an application where the back end part of the data, the model part, and the controller part, are fine. They've been working great, doing the job that they're supposed to. But maybe the user interface is a little outdated and it looks old. You can update that user interface. And as long as you don't make too many changes, that can be plugged right back into the application and be updated without ever having to make any changes with the controller or with the model part of the program. All right, and then finally, it's easy to have multiple views for a given model, right? So you can have multiple views that display the same data. So you might think about the data, let's say, you might have a bar chart to display some data, and then you change it to a scatter plot or line chart or some other type of thing like that. Since it's separated right out, you can just create another model and then just add that into as into your application as a different display of the same data. The data is separate, so the view can just go get the data from the model and display it in a different way. So it's easy to add those things in to your application. Okay, so that's a general overview of what the model view controller part is. Again, the view and the controller, we've been doing that, right? The view for us has essentially been the FXML file that contains information about the user interface. The controller class, right, is the controller in the programs that we've been making. Okay, and so now in these examples, we're going to go over these examples: Loan Table, Paint App, and Database Query Project. What we're going to do is show you how the model is implemented in these three examples. Okay, so that's what we're going to focus on. So in the applications, in the examples that we will go over, then we will have basically, I'll start where the model and the view and the controller have been implemented, and then show you how to add a model class on the top of that. Okay. All right, so that is it's on here. I'm going to separate these examples out into their own videos.